We're going to be looking at some word problems or applications that involve exponential functions, and they involve what we call either exponential growth or exponential decay. So exponential growth would be some sort of application where something is increasing exponentially. An example could be investing money. The formula looks like this. So f of x equals a times b, and the exponent is x over p. Now that is if something is growing by a factor. So if something is doubling or tripling or something like that, or it could grow by a percent, in which case the formula looks like this: f of x equals a times 1 plus r to the x over p. So this would be if something is increasing by 15% or 7%, something like that. So the letters, the A represents the initial amount. The X represents, that's the numerator in the exponent, that represents how much time has passed. The R in this example would represent the growth rate, and it would be given to you as a percent. You would have to change it to a decimal. The B in this question would be the growth factor. So if it was doubling, B would be 2. If it was tripling, B would be 3. The P is the growth period. So that's the denominator of the exponent. The growth period may be like if it is doubling every year, then P would be 1. If it's doubling every 2 years, then P would be 2. And Y, which of course is the same as f of x or y, just represents the amount after the time has passed. Now, sometimes you'll see the equation written like this. It's pretty much the same thing, but P with a subscript of 0 just means the initial amount, and they usually just write x as the exponent, but the exponent could be a fraction, so you'd have to keep that in mind. So we'll look at the first example. In 1995, there were 85 rabbits in Mulock Park. The population quadruples every 8 years. How many rabbits were there in Mulock Park in 2009? So because this is quadrupling, we're going to be using the first formula. So it's going to be f of x equals a times p times b to the x over p. Now your variables. The a is the initial amount, which is 85 rabbits. The b is how much it's increasing by, so it's quadrupling, so that's 4. The x is how much time has passed, so that is the amount of time difference between 1995 and 2009, which is 14 years. And the p is how often the amount is increasing by. So it's quadrupling every 8 years. So that's the value of p. Now, when you substitute these into the equation, so x is 14, so f of 14, remember you put the number in the bracket represents the number that you were substituting in for x. So f of 14 is equal to, we're starting with 85 rabbits, and it's quadrupling, so it's multiplying by 4. And there's 14 years, but it's happening every 8 years. Now, in your calculator, this is the way you would type it in. 85 times 4. Now, you're going to press whatever your exponent button is. Depends on your calculator. So most would be like a y with an x, but some people's exponent buttons are different. And then you would type in a bracket, and then 14 divided by 8, close the bracket, and then equals. Now, that works out to approximately 961.7. But since we're talking about rabbits, you can't have a 0.7 of a rabbit. And normally with rounding, that 7 would round that up to 962. But what you have to think about with these examples is we are stopping at in 2019. So in 2019, we don't actually have 962 rabbits yet. So that 0.7 means, I don't know, I guess one rabbit is still pregnant, hasn't given birth yet to that 962nd rabbit. So in this case, there's actually only 961 rabbits. So you have to think about it a little bit to see which way you're going to round it. Next question. In 1985, there were 285 cell phone subscribers in the small town of Mathville. The number of subscribers increased by 75% per year after 1985. How many cell phone subscribers were in Mathville in 2010? So in this question, it's increasing by a percent. So we're going to be using this formula. So that's going to be f of x equals a times 1 plus r to the x over p. So the a is the initial amount, which is 285. The r is the growth rate, which is 75%. And we need to put that in as a decimal, so it's decimal 75. The x is the amount of time, so the amount of time between 1985 and 2010 is 25 years. And the p is the time period, so how often is it increasing by 75%? It's per year. So that means the p is just equal to 1. All right, so we're going to substitute 25 in for x. So that means we are starting with 285 cell phone subscribers, and it's increasing by 75%, which is 0.75. And the time is 25. And because p is 1, that would be divided by 1, which we don't need to write. If you wanted to, you can write this as 285 times 1.75. It doesn't really matter. And in your calculator, that is going to end up being equal to 339,465,839.1. And sorry, that should be approximately. And so once again, no matter what the decimal is, we are going to round down. So it doesn't matter what that decimal is, you round down because we haven't actually made it to that 840 yet. So there are approximately 339,465,839 subscribers. And just made me realize that over here we should say approximately. All right, last example. A bank account starts with a balance of $100 and has an annual interest rate of 4%. If the money grows to $160, how long was the money left for? Now here's the difference, is that they've actually given us what the final amount is, 160. What we're being asked for is how long was the money left for. So what we're solving for in this case is the x. Now, because it's increasing by a percentage, we're going to be using this formula. And this time we know that the final amount is 160. The opening amount is 100. The growth rate is the R, which is 4%, which is 0.04. The X in this case is what we don't know, so that's what we're solving for. And the P is equal to 1 because it talks about an annual interest rate, so that's just for 1 year. So when we substitute that in, the final amount, which is f of x, is 160. The beginning amount is 100, and that's 1 plus 0.04, and x is what we're solving for. Now we can simplify this a little bit. So the 1 plus 0.04 is 1.04 to the x. And we can also divide both sides by 100. And that would give us 1.6 equals 1.04 to the x. Now, at this point in time, in grade 11, there's no way to actually solve for an exponent. In grade 12, you learn it, but in grade 11, there's no actual way to figure out what the exponent would be for this to be equal to 1.6. So what you have to do is a little bit of guess and check. So pick a value like 10 and try it. 1.04 to the exponent 10 is approximately equal to 1.48. So we need to go a little bit higher than 10. Let's maybe try 15. So 1.04 to the 15 is approximately 1.8. So that's too low. So let's try maybe 12. So 1.04 to the exponent 12. 1.04 to the exponent 12 is approximately 1.6. Now it does say to round to one decimal place. So this is 1.6010. Now that's pretty close. If you were to try the exponent 12.1, you would end up with 1.607. If you were to try maybe the exponent of 11.9, you get 1.5947. So 1.04 to the 11.9 is approximately 1.5947. 1.04 to the 12.1, I said, was approximately 1.607. So it does look like this is the closest one. So you do have to get into checking those decimal places just in case. And then we can say, therefore, it would take approximately 12.0, because it was right on 12 years. So unfortunately, it is just a guess and check. There's no easy way until you get to grade 12.